Hi, I want to talk to you about a buffer and products lab. This one really, here's the driving question. What is the buffering capacity of different products that you and I consume? I have an example here that we are going to be looking at, say, the buffering capacity of, actually we'll do this example, of Alka-Seltzer. Okay, what's the buffering capacity of this? So here's your first task. Whatever you're given, you have to make it into a solution. So honestly, I would take this and I would make the Alka-Seltzer according to the directions because that's what we consume. Let's say that you're given tomato paste. Well, that's, kind of a smushy solid, for lack of a better word. You are going to take that, take a tablespoon and dissolve it in at least 50 mils of water, at least 50 mils of water. You want to have at least 25 mils that you can test an acid with and 25 mils that you could test a base with. Let's say that you already have a liquid, pineapple juice. So then I would take, say, 25 mils of pineapple juice, test it with the acid, 25 mils of the pineapple juice, test it with the base. Now, if you have a hunch or you look up what's inside of pineapple juice and you go, I think the concentration of citric acid is going to be kind of high, then do 10 mils of the pineapple juice and then add distilled water to it to bring it to 25 mils. And that's totally fine. That's totally fine to do that. You'll still be able to see the buffering ability of that particular substance. So you have to have it in a solution. This right here is a solid. A tomato paste would be a solid, but then you could have some solutions like, a sports drink or a juice. You could even do like a cleaning supply and test the buffering ability. So number one, you've got to get it in a solution. You need at least 50 mils. Then what you're going to do is do a titration. And so here I have my two burettes, and you'll notice that one of them I have marked acid, and I did it with orange tape, and one I marked base with yellow tape. I wanted it both visual and written so that I don't get this mixed up. So you'll take your 25 mils of each. I'm going to start with my acid right here, and I would put in half a mil. Okay, so I'm going to record the pH, put it in a half a mil, record the pH. Put in a half a mil acid, record the pH. Put in a half a mil acid, record the pH. You just go every half mil recording the pH and see what amount, what volume of this acid could you add for it to still maintain a pH within 1 point. So let's say that I have a pH of 6. I'm adding acid. How much acid can I add until it hits a pH of 5? Then you take your second container with the 25 mils, and you're going to do the same thing. So let's pretend this is my second container. And now I'm going to add base to it. So you add half a mil of base, record the pH. Half a mil of base, record the pH. And again, you're asking the same question, how much base can you add? And it's still within 1 pH point. So again, if my solution is a pH of 6, what's the volume that I could add of that base and it will be a pH of 7 or less. So you're just looking at the strength of a buffer. That's really it. So two things. Number one, whatever substance you're assigned, get it in a solution form. Record exactly what you have and how much you used. You're going to split it into two 25 mil samples. You're going to have them each in an Erlenmeyer flask. And then you record pH as you add an acid, as you add a base, and you're going to see what volume you can add of each to maintain that plus or minus 1 pH point. And there you have it. It's really exploring the strength of buffers in substances that we use in our lives. So there you have it. Good work, have a good day, and have fun in the lab. Be careful. All right, thanks.